Well, I'd like to start things off by thanking you for taking the time to attend our presentation today. My name is Lance Zurich, and what we're going to do today is take a brief look at the two special curriculum-based sets from Studica that are designed for introducing students in middle schools, high schools, and even in homeschools to the fundamental principles behind mechatronics. Now, each of these sets are designed for conducting a project-based class where students are going to be required to design and build a series of original prototypes based upon their own research and activities. And each set includes standards-focused curriculum, which was created especially for Studica by noted educator and STEM expert Tom White. So today we're going to start off where so many technology-focused presentations for education seem to start these days, and that's with the skills gap that exists. Now, when you hear someone reference the skills gap or talk about the need for better STEM education in the schools, STEM, of course, being an acronym which stands for science, technology, engineering, and mathematics. Well, when you hear someone saying this, what they're essentially talking about is that there is an urgent need to prepare our students with the background that they're going to need to successfully compete in the job market that they're going to be graduating into. Now, in the employment market that once greeted our grandparents or even our parents, a good work ethic, a strong back, and basically being able to take direction on the fly might have been enough to land a good paying job where many of the technical aspects could be learned along the way. But now students must be prepared to enter a world that is increasingly focused on things like programming, automation, IoT, and all sorts of rapid advances in all aspects of technology. So because of this, students must be able to demonstrate technical literacy and aptitude if they hope to compete and succeed. And this is, of course, why so much of the emphasis in education over the last decade, probably even a little longer than that, has been on developing STEM skills. Every new advantage that we enjoy, things like the tablets and the smartphones that all of us use daily, all of these things were created because of individuals who helped to make those advances. Countries all around the globe, like China and India and so many others, are making major strides in developing new technological advances and preparing their own students to take place in the future workforce. Now, here in the United States, we also need to prepare the next generations of graduates with the skills, the mindset, and the habits that will enable them not only to secure jobs, but also to be a part of the next wave of advancements that we do rely on to stay competitive on the world stage and to maintain our stature as a world power. So it's twofold. It's for the students, and it's also on a national level, it's for the country to maintain our stature. Now, as I have no doubt that anyone attending a webinar like this is, of course, in agreement about the importance of STEM and technology-focused programs, we're really going to move right along to the main topic, which is, of course, mechatronics. Now, mechatronics has been called the science of intelligent machines. It's a study that focuses on electrical systems, control and mechanical systems, robotics, the Internet of Things, and computer science. All, of course, extremely important subject areas for students to be exposed to, and all skill sets that are very highly prized in today's technology-focused job market. But just how prized are they? Well, per the website careerexplorer.com, the average salary for a mechatronics engineer in the United States is currently around $96,980 per year. So while, of course, the students who go on to secure these prized career positions are the ones who prepare themselves by pursuing the proper post-secondary coursework, they do need to start developing those habits and that career focus as early on as possible in high school, if not even probably in middle school. Now, the dilemma for educators, whether you're in the classroom or the homeschool environment, is, of course, finding ways of introducing this type of subject matter to students in a way that gets them interested and involved in the learning process and not just memorizing obscure facts or ideas for the only purpose of taking a test and then promptly forgetting them. What you really want to do instead is to help students to be successful and to really encourage them to consider pursuing further education in subject areas like this. Educators need to be able to present the material in a way that makes it relevant. And this also means answering that eternal student question, which is, why do we need to know this? You need to show them why it's important. And it also needs to be engaging in a way that holds student attention better than rote textbooks and lecture presentations and and things of this nature, something that has real, visible, real world applications in which the students can get involved in doing things hands-on. So it's with this dilemma in mind that we created the Studica Mechatronics program. These two special sets, one of which is designed as an introduction to the world of mechatronics, and the other, which is intended to be essentially a standalone class dedicated to the subject of mechatronics. These were created to provide all of the materials in one place that educators would need to enable them to offer a project-based class that it's relevant, that's engaging, that's realistic, hands-on, of course, and which is crafted to meet the most current academic standards. Each of the two Studica Mechatronics program sets comes with its own detailed day-by-day curriculum document, which was, again, created especially for Studica by noted educator and STEM expert Tom White. The curriculum itself comes as a downloadable PDF, which is available for free with the purchase of each set. This curriculum is designed to align to the most widely accepted academic standards that are currently in place in the United States. And the curriculum is also designed for offering a project-based learning program. And again, this means that the problem solving of the problems that arise in each of these units will require the students to be actively involved in the research, the design, the trial and error experimentation activities, and the building of actual working prototypes that will provide the required answers. And students won't do this alone. They'll be asked to work in small groups or teams of 4 students each. And this is going to help them to develop the soft skills that students also need, maybe just as much as they need to develop technical skills. And when we talk about things like soft skills, we mean things like communication skills, teamwork, adaptability, problem solving, and of course, leadership. And finally, with the exception of some very, actually, the software now that was normally would have cost you in addition, it's now given free with this set. And so everything you need is included, physical building materials and everything else that the students are going to need to address all the design projects presented throughout the course of the curriculum. Now, the curriculum itself is designed to enable teachers of all backgrounds, keeping in mind that even you'll have a lot of teachers who get involved with programs like this who aren't from a science or a technology-focused background. Because of this, it was designed to provide those types of teachers with all of the information they're going to need at hand to properly prepare them for conducting the activities and also to increase their comfort level in presenting this type of material to the students. The curriculum is designed to be very clear and easy to follow, and it provides a clear roadmap for student learning. Various supplemental materials are included both in link form throughout the curriculum and also at the end of each unit. And there are also special tutorials to help familiarize students with the building system they're going to use to address the projects being presented in each of these units. The units in the curriculum are designed as a series of projects. Each of these projects is presented to students in the form of an engaging real-world style scenario where students must work together in small teams. Again, these are teams of 4 students per group to create a solution. The project units each contain embedded academics. And at the end of each unit, the students will be required to make a formal presentation of the prototype that they've created to address that particular unit's real-world style scenario. And their students are also going to have to explain the reasoning behind the way they constructed their prototype and made the decisions that they did. There's also a technical literacy task that's driven by each of these projects. As students work to address each project, they acquire the knowledge that they need through inquiry and exploratory research. Science, math, and technical skills are all acquired through the carefully designed enabling activities. And again, as required by each project, students will be asked to create original prototypes. And of course, they're going to need to create and required programming-based solutions as well, and also to maintain detailed documentation during this entire process. Now, as I've mentioned his name a few times during the presentation, again, the curriculum that accompanies each of the Mechatronics program sets was created especially for Studica by a man named Tom White, who you see on the screen now. Now, Tom is a noted educator who's been involved in teaching STEM and technology since the 1970s, designing programs for educational institutions and for industry. In fact, as an expert in hardware and software integration, Tom was pivotal in introducing CAD, CAM, control systems, digital control, additive manufacturing, and other like topics to the classroom. Now, currently, Tom is the Director of Technology for STEM curriculum at the globally recognized industrial manufacturing company, Siemens. The standards addressed in the Studica Mechatronics programs are the most widely accepted standards that are currently in place in the United States. And this includes the college and career readiness standards for mathematics, reading, and writing, as well as the next generation science standards for K-12 and the standards for technological literacy. And as I mentioned earlier, the programs are designed to be project-based. So when students ask, why do we need to know this? It's usually because the subject matter that they're being presented with might come across as too abstract to ever be useful in their lives. And we've all heard students say things like that. Now, with this project-based approach, students get to see firsthand why these things are necessary to know and why they're useful. The concept of working in the small groups to solve the projects and problems helps students to develop the high demand soft skills that I touched upon before. And again, these are things that employers really look for in students. And again, it's things like working on the communication skills, the analytical skills, the quantitative skills, flexibility, adaptability, and of course, problem solving. In this project-based format, all of the subject matter is integrated, meaning the math is integrated with the reading and the writing and so on. And this type of approach is really ideal for STEM education. And also because of the manner in which students must approach each of the projects being put forth in the curriculum, again, with the research phase, the testing, and all of the group give and take, just to give you a couple of examples. Because of this, it allows for a much deeper exploration of problems than traditional teaching methods, again, just rote textbooks and lectures. It gives a much deeper exploration than those methods would. And the projects presented in each of these units are also designed so that you have, as you will probably have several groups working on the same project at a given time, that as a teacher, you should see variations in the prototypes and the solutions that are being put forth by the students. And this, of course, can be because of differences in creativity, differences in research, and the different approaches, of course, taken by each team. But in any case, what this helps students to see firsthand is that problems can have many different answers and many different ways to solve them, and that there's not always only one right answer. Each project in the curriculum presents students with the opportunity to plan, to organize, and to conduct research. The enabling activities that students are asked to engage in provides them with the skills and the knowledge that they will need to draw on to complete each project just in time. And students will be required to do extensive research as they complete these projects, research that is utilized again in the design, the prototyping, the testing, the evaluation, and the redesign phases of each of these solutions. And once again, the Studica Mechatronics sets are designed specifically for students to work in groups. Each set contains enough materials for teams of 4 students. The team approach, as stated before, again, is because we want to help promote soft skills. Again, things like communication, the ability to work well with others, and leadership. And because of this structure, the sets offer an easily scalable approach. All you have to do is divide the number of students in your classroom by 4 to determine the number of sets that you would need for each class. And once again, everything you need to conduct the program is included inside of each box. Aside from some downloadable materials, the downloadable curriculum, and the downloadable software, as I've talked about before, everything is included with the purchase of each set. And also included are all of the building materials which students will use in the creation of their prototypes. And these materials all come from the unique Fisher Technic building system. And among the components included in each set are 2 robotics controllers and 2 power supplies. Now, of course, as many of you may not be familiar with Fisher Technic, just allow me for a minute to provide you with a little bit of background. Fisher Technic is a flexible and innovative construction system. Now, unlike other popular construction sets that are designed to simply stack, the Fisher Technic system was created with more of an engineering mindset in that the core building block in the system is unique in that it allows attachment from all 6 sides. And because of this feature, it allows for almost limitless design possibilities. Many of the parts in the system are designed to slide together and lock in place using a tongue and groove assembly method. And the system also includes a very wide selection of very specific parts. This can be variations on gears, girders, sensors, and much more. And because of this, it allows technical builders to address equally specific design needs. The system was created back in the 1960s, by German inventor Arthur Fischer, noted for countless innovations used in both construction and the automotive industries. Now, Mr. Fisher, at the time of his death, which was in 2016, at that time, he held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Now, besides Fisher Technic, Mr. Fisher was also the inventor of synchronized flash photography. That was back in 1949. And he's also known as the creator of the expanding nylon wall plug, which is commonly used in conjunction with a screw or a bolt to help anchor heavy objects to walls. His company, the Fisher Group, still employs thousands of workers worldwide, producing many variations of fastening devices used in building construction, as well as many components used in automobile manufacturing, and they also provide consulting services related to high-end automated processes. Now, with all that being said, let's begin looking at each of the two individual sets, and we're going to start off with the Studica Introduction to Mechatronics Program set, or for those of you who like acronyms, you could refer to it as SIM. The set is designed to help provide a well-rounded introduction to the core concepts of mechatronics. Each set includes access to a free downloadable 242-page curriculum document entitled Mechatronics Fundamentals, written by Tom White. The curriculum contains enough activity material to fill approximately 45 academic hours. And as such, we recommend this program set for insertion into regular related class activities. It could be used as a short class unto itself. It could be used for after-school program use, or of course, it would be great for homeschool use as well. The curriculum created for the set is, again, standards focused, using the academic standards most widely recognized in US-based education today, and it's designed for offering a project-based program. Set is again designed for use in middle or high school classes, or again, for addressing these same grade levels in a homeschool environment. The set itself contains a collection of over 700 Fisher Technic building components, and this will include a variation of gears, wheels, axles, blocks, sensors, and much, much more, as well as, again, the 2 robotic controllers and 2 power supplies. Only the software, which, again, you'll have to download separately, is not in the box. And otherwise, you have everything there that you need, and you just have to, of course, as I said before, decide how many sets you need for your particular classroom, divide your number of students by 4, and you'll have the number of sets that you need. The curriculum for the Studica Introduction to Mechatronics Program set consists of 6 project units, and they are as follows: sketching and documentation, simple machines, mechanical systems, basic electricity, conversion and storage of energy, and an introduction to control systems. And, excuse me. There are also activities included to address the following topic areas that come up during the course of the curriculum. This will include areas on sketching, linkage diagrams, schematics, Ohm's law and power, pneumatics, flowcharts, using software and robotic controllers, working with sensors such as the digital switch and the digital photo transistor, working with open loop and closed loop programming, digital branching, working with analog sensors such as the photocell LDR, working with analog branching, and more analog sensors, the NTC resistor, and the potentiometer. Now, before we go further and look at the structure of the curriculum, we're going to instead jump and see what's covered by the second set. Now, again, the second set is called the Studica Teaching Applications of Mechatronics Program. And if we want to consider acronyms, again, you could call this one STAMP. This set is designed for those educators and homeschoolers who wish to provide a more in-depth exploration of the fundamental aspects of mechatronics. The set itself comes with access to a free downloadable 400-plus page curriculum document, this time titled Mechatronic Applications, again by Tom White. And the activity materials in this curriculum document, when used in conjunction with the contents of the set, are designed to fill approximately 180 academic hours. So essentially, we're talking about covering 4 times the amount of academic hours as were addressed by the first set. And because of this, you can think of this as a more expansive version of the material being studied, and that it's really designed for those educators who are able to dedicate a daily class period of approximately 50 minutes a day, 5 days a week, or the equivalent. If you do it all in one day, you could do that as well. But essentially doing a 50-minute a day, 5-day a week class for a full academic year. So of course, this is probably going to be less suited to work into other class activities. This almost needs to be a class unto itself. Again, the set is designed for offering students a standards-focused, project-based learning experience, and it's designed for use in middle school and high school, or again, for addressing the same grade levels in a homeschool setting. The materials in the set will, this time, include a selection of over 1,200 Fisher Technic building components, and this will, of course, include more of the gears, the blocks, the sensors, possibly many different pieces than you would see in the first set, as well as, again, 2 robotic controllers and 2 power supplies. And again, the software that you're going to use for this is downloadable. Now, there are twice as many project units included in the Studica teaching application of Mechatronics program set as with the previously discussed set. And this will include units on sketching and documentation, simple machines, mechanical systems, basic electricity, as well as project units focusing on the creation of a garage door, an elevator control, an automated pneumatic clamping system, an automatic pneumatic feeder system, a conveyor with a counter, a robotic control, a sun tracking solar panel, and a color sorting machine. And again, during the course of the curriculum, there are links that are provided to tutorial sections and activity materials for students to utilize. And this includes sections on sketching, linkage diagrams, schematics, Ohm's law and power, flow charts, using the programming software and robotic controllers, working with open loop programming, working with sensors such as the digital switch and the digital phototransistor, working with closed loop programming and digital branching, learning about logic gates, combinational logic, edge triggered versus level triggered, pneumatics, variables, positions, learning how to record positions, creating a graphical user interface, working with analog sensors such as the photocell LDR, the NTC resistor, and the potentiometer, and also working with data. So now that we've had a chance to look over how each of these sets differs and look at the specific subject matter being addressed by each set, what we're going to do now is we're going to look at exactly how the curriculum itself is structured. Now, both versions of the curriculum do share the same essential format. So when you see me talking about the way that each unit is approached, it's essentially going to be a similar approach for each of these sets. And again, as already discussed, each version will include tutorial materials, activity materials, standards, and of course, supplemental materials. Now, in each case, the curriculum is designed to be turnkey. And what do I mean by that? Well, essentially, each unit is designed to clearly spell out everything that's going to be addressed. And again, it provides tutorials and other information as various topics are brought up. Now, this was done specifically to enable teachers from all types of backgrounds, including those teachers especially who come from non-science and non-tech focused backgrounds, like how often do you see possibly one of your fitness instructors who ends up being involved with a robotics class. So this is basically designing to, wherever you come from, to give you to, as they say, pack your parachute so that you should be comfortable in teaching this class, and then you'll quickly become comfortable with delivering the material simply by reviewing each section before you present it. Each unit presented in the curriculum for each of the sets includes the following sections. It will include an introduction, the purpose of the project, the concepts being addressed, an outline of what will be covered. All of the standards are spelled out. There are assessment rubrics that are provided. The essential question is put forth. The student scenario elaborates on that, gives them that real world style scenario I talked about before. There's a daily plan about how things will be addressed. And then you have things like vocabulary and resources, which will be various additional things, PDFs, videos, what have you. So now we're going to take a look at each of these sections a little bit closer. When you see the introduction and the purpose of the project, of course, this starts out with an introductory section. And just as you would likely gather from the name, this is the section that provides a brief description right at the top of what's going to be explored in the coming days and activities. And this is also the section that seeks to clearly spell out to the students why they're learning this material and why it's important for them to know. The next section focuses on the main concepts being addressed in the particular unit, and these can be thought of as the broad ideas that are going to be explored in the unit and the core information that students should take from this project that's going to be essential for them to understand and utilize not only today, but also to draw upon as they move forward in STEM fields of studies and, of course, if they choose to pursue it, in STEM-related careers. Following this, we encounter the outline. Now, in this section, we're going to drill down more specifically to what's going to be addressed in the unit. So as the example that I'm sharing on the screen right now is taken from a unit that addresses aspects of programming, you will see that we touch upon areas such as the methods for writing programs, which would include flow charts and word problems, program characteristics, for example, open or closed loop, dealing with branching, digital, analog, subprograms, and so on. Next up, there's a section where each project unit that focuses on the specific academic standards that are going to be addressed in that particular unit. And again, this will include the college and career readiness math standards, the reading standards for literacy in history and social studies, the writing standards for literacy in history, social studies, science, and technical subjects, the National Research Council's Next Generation Science Standards for grades K to 12, and the standards for technological literacy. Each project unit also contains rubrics, and this is going to include both rubrics specific to the project unit being covered, and also general rubrics for the literary tasks being addressed. Next, we come upon the essential question. And this can be thought of as kind of the big picture question that we're going to focus on in each of the smaller individual activities. And of course, all of the aspects of the larger project where students are going to be asked to complete in this section, the project they're going to work on. The student scenario is where the specifics of this project to be addressed are finally spelled out. And it's presented in the context of a real world style scenario where students are presented with a problem that needs to be solved. And they're going to be asked to create some sort of device, a machine, or a mechanism, what have you. Now, as I mentioned before, students have to work in these small groups to craft these answers to the challenges. And solving this problem is going to require each team of students to design a unique and original answer, which again, usually will take the form of some sort of working prototype, a machine, a device, what have you, along with whatever programming may be required. So just to provide an example, if you look closely at the student scenario that I'm sharing on the screen right now, you will see that the project unit that's being discussed has each group of students take on the role of a member of a design team employed by a firm that manufactures garage door openers. Now, in this particular case, the students are being required to design a very specific type of control system for a new line of garage doors. Now, the manufacturer's requirements are all spelled out, and they have things in mind, such as they want to have limit switches or meeting certain safety codes that require a method for sensing if anything's in the way of a closing door, and also the incorporation of an automatic light. Now, again, each team of students is going to be tasked with creating both a unique and original prototype. And of course, it's obvious in this case, the prototype is the garage door opening system, as well as the programming needed to control the prototype. Now, as students move through the challenge being put forth in this scenario, each student team is going to be required to document the entire process in both a design notebook as well as a digital engineering journal. And this means notating all of the research, all of the trial and error experiments, keeping copies of any design sketches and revisions that they make, and so on. So anything they do, they need to record it. And at the end of each project unit, each of these teams of students is going to be asked to make a formal presentation in front of the class, during which they're going to be asked to demonstrate whatever their prototype is that's the answer to the students or their real world style scenario. So they're going to have to present their model in action, their machine in action, and they're going to have to discuss why they made the choices they did, just much as you would if you were actually employed by someone to create this machine or device or what have you, this solution. You have to explain your reasoning for it and present how it works and show how it solves the problem. Now, in the next section, we encounter the daily plan, and this is the section that clearly spells out, both for students and the teachers, what's going to be expected of the students, how the teacher is going to conduct that day's class activities, and what specific subject matter is going to be covered. So as you'll see, some days may involve discussions. It's not about working on something physically, it's going to be about discussing different ideas. Other days may be more focused on research or perhaps the building of small projects that will help provide the basic building blocks that students are going to draw on to complete the larger projects that are described in the student scenario. But essentially, you can think of the daily plan as a roadmap that's designed to keep everyone on the same pathway. And you will see, too, along the way that as different aspects are addressed in each day's activities, such as when a design notebook is brought up or discussion of how to use the control software, working with the controller, or working with flow charts or what have you, as each of these types of things comes up, there are going to be links that are embedded inside the curriculum that will provide further instructions and information on each of these areas. Now, at the completion of each unit, after the last day of the daily plan, there's also a section that contains vocabulary, and these are important words as well as terminology introduced during the project unit. And there's also a selection of useful resource materials. And these resource materials can be a mix of different types of material. It could be carefully vetted websites and video links, could be PDF documents, could be PowerPoints, what have you. It's going to depend on the particular section, but there are always additional resource materials that are included. Now, besides the project units, each of the curriculum documents also includes a special tutorial section designed to educate both the students and the teachers on how to use the Fisher Technic building system. And this is going to include information on how the various parts will fit together using, again, that pin and groove assembly method I talked about, how to identify the different types of parts from knowing what are the different types of girders and blocks, the different types of axles, gears, rivets, and so on. And students are also going to be asked to build a very basic sample model just to help familiarize them hands-on with using the system before, of course, they're being asked to move on to those bigger projects in each unit. And as, of course, learning and maintaining proper documentation is one of the areas that we stress throughout the course of this curriculum. There is a section that details just what defines each type of documentation, such as the forms listed right now on your screen, and what is required of each of these. So what do students need to have for a problem statement? What do they need to have for a design brief or a project management plan and what have you? That's all spelled out here as well. And because this process of conducting this type of more open project-based class activity might be new to many teachers, there is also a section that discusses specifically project-based STEM education and its benefits. Now, that essentially completes our overview of these two sets, but let's quickly review the contents and purpose of each set, but this time I'll provide you with the pricing. First off, we have the Studica Introduction to Mechatronics Program set, which again is designed as a standards-focused, project-based introduction to the core concepts of mechatronics. Again, it includes the highly detailed 242-page curriculum document entitled Mechatronics Fundamentals, again written by Tom White. And the curriculum, when used in conjunction with the building materials in this set, will provide teachers with enough activity material, again, to fill approximately 45 academic hours. So again, this is designed for those educators who wish to offer either a shorter class on mechatronics who would incorporate it into other class activities. You could use it for an after-school program or, of course, for homeschool use. The teaching materials designed for use in middle schools and high schools, again, as well as by homeschooling parents who are seeking to address STEM and mechatronics for these particular grade levels. The physical materials included in the set are, again, a selection of 700 components from the Fisher Technic building system, your blocks, your gears, your sensors, your robotic controllers, your downloadable software. And these are the materials that, again, are going to be used to construct the mechanical prototypes addressed in each project unit of the curriculum. Again, it's designed to be used by a team of 4 students at a time, and the pricing starts at just $699 for a single set. And there is also discount classroom pricing for groups of 20 students and up, which is available by quote upon request. So if you want that, you can just reach out and we'll be happy to quote you. Next, the Studica Teaching Application of Mechatronics Program set. Again, this is designed as a more in-depth, still standards-focused, project-based exploration of fundamental aspects of mechatronics, and it's all based around a highly detailed 400-plus page curriculum document entitled Mechatronic Applications, again by noted STEM expert Tom White. Now, when used in conjunction with the building components included in this set, the curriculum is designed to provide enough activity material to fill approximately 180 academic hours. Again, this is a much longer set, so it's really designed either for those teachers or homeschoolers who really want to take a deeper dive into this. Essentially, you're looking at 50 minutes a day or the equivalent for 5 days a week, depending on how you approach it, for a full academic year. That's how much material you will have here. Set is again designed for use in middle schools and high schools, as well as by homeschooling parents who are seeking to address these topic areas of these grade levels. Each set contains an assortment of over 1,200 components from the Fisher Technic building system. Again, all of your gears, your blocks, your different pieces, sensors, and of course your robotic controllers and your 2 power supplies, and you get your downloadable software as well. Again, each set is designed for use by teams of 4 students at a time, and the pricing for a single set on this set is just $799 per set. And again, we do offer discount classroom pricing for 20 or more students, available by quote upon request. The software, I just kind of touched on it before. What they're going to be using is Fisher Technic RoboPro. This is a graphic programming software. It's designed for Windows version 7, 8, and 10. It does not work with Chromebooks, and unfortunately, this is not a Mac-friendly program. The software, which we used to charge for when we started out this presentation, but now it is available for free download directly from the manufacturer's website, fishertechnic.de. We, of course, would provide complete details on that when you make a purchase. So at this point, if you do have any questions, you could use either the question and answer window or the webinar chat window, both of which are located on the Zoom toolbar. You could just type in any questions you have. I will keep things going if I don't see any typing going on and give you some steps to take. So if you'd like to take the next step, if you'd like to request a quote, if you would like to speak with your dedicated educational representative, whichever state you're in, you can call us. Our number here toll-free is 888-561-7521. If you have general questions, this might be quote requests, what have you, you can just simply email us, info@studica.com, studica.com. If you have any questions specifically for me, anything that I brought up during the presentation, any aspect of the sets or of the Fisher Technic product line that you would like to know about, we do offer the full Fisher Technic product line for education. It includes many sets for addressing different areas of STEM, specifically things like renewable energies, pneumatics, electronics. We have a really nice line of robotics products, more advanced robotics products that you may want to know about. And we also have higher end things if you're talking about a vocational VOTEC type class in a high school setting, or in higher ed, we do have industrial simulation and training models that we offer that are used with commercial PLCs. I can tell you about those as well. But any of those things, if you'd like to know more, you can email me directly, lance.zurek, lance.zurek, @studica.com. So on that note, I'd like to thank you very much for taking the time to attend today's presentation. Have a great day. We look forward to hearing from you soon. Take care.